Hello, my name is Itamar Cohen, and I am a postdoc fellow at the Politecnico di Torino. I will present the paper on the power of false negative awareness in indicator-based caching systems. This is a joint work with Einziger and Gabriel Scalosub from Ben-Gurion University of the Negev, Israel. Network caching is a fundamental building block in numerous networking environments. Commonly, a user is equipped with one or more caches. When the user fails to retrieve a requested datum from a nearby cache, the user has to access a remote server, resulting in high penalty in terms of delay, bandwidth, and energy. To help the user deciding which cache to access, the caches commonly generate and advertise indicators. An indicator is a compact representation of the list of items currently stored in the cache. Now, when the user is looking for a datum X, the user can know which of the caches is likely to store this requested datum, access this cache, and obtain the requested datum efficiently. This advertisement mechanism is commonly used in various networking domains, such as content delivery networks, 5G networks, and information-centric networks. Let us understand the source of false negative events in such advertisement of indicators mechanisms. Consider a cache which generates and advertises an indicator. Now, after the cache advertises the indicator, the cache replaces some of the items it contains. Now, when the user is looking for datum 666, this item is actually found in the cache, but the user doesn't know that because this item was inserted into the cache after the last advertisement of a fresh indicator by the cache. Therefore, the user looks for the datum in a remote server, resulting in a high penalty, while the datum is actually found in the nearby cache. This is a false negative event, namely, the requested datum is actually found in the cache, but this is not reflected in the indicator which the user stores. This figure shows the false negative ratio as a function of the update interval, namely the number of insertions of new items into the cache between subsequent updates or advertisements of a fresh indicator. Observe that both axes are logarithmic. The plot shows a steep increase in the false negative ratio as a function of the update interval. In particular, note that when the update interval is above 1K, the false negative ratio is at least 10%. Our solution for the problem includes the development of a lightweight dynamic false negative aware algorithm. Our algorithm estimates the current false negative ratio, and when the estimated false negative ratio is high, our algorithm selectively accesses caches even upon a negative indication. We will now visit a sample of our extensive evaluation study. The figure shows the expected cost of a data access for several commonly used real-world cache traces. The white rectangles show the cost obtained by state-of-the-art false negative oblivious access strategy, while the blue rectangles show the costs obtained by our false negative aware algorithm. The figure shows that our algorithm obtains much lower costs for all simulated traces across the board. This figure shows the expected cost of a data access for the wiki trace when varying the update interval. Observe that when increasing the update interval, both the false negative aware and the false negative oblivious access strategies show an increase in the expected cost. However, our suggested false negative aware algorithm shows only a very mild increase in the cost, while the state-of-the-art false negative oblivious approach experiences a very steep increase in the cost. In particular, the cost obtained by our false negative aware algorithm when the update interval is 8K is lower than the cost experienced by the false negative oblivious approach when the update interval is only half K. This shows that our algorithm obtains a lower cost while using 16 times lower bandwidth consumption for the advertisement of indicators. To conclude, staleness of indicators cause false negative events. Our false negative aware approach reduces costs by estimating the false negative ratio and selectively accessing caches with negative indications whenever the false negative ratio is high.